Well, hello friends, welcome back to browser hacking. Today we are going to look at google.com in the browser because Ali, who has been working on the TLS and HTTPS implementations, has today gotten Google to load in our browser. And I tried it here locally and it doesn't quite go all the way because we have an assertion in UTF-8 view when we are trying to do something. So I figured today we would work out what the issue is and see if we can get Google rendering in the browser here as well. So we are in libweb and doing HTML layout, and we are trying to lay out an HTML input element, and we are trying to measure some text. So presumably we have some input element on google.com with some text that is not valid UTF-8. Now that's super possible, super plausible that would happen, since we're kind of just assuming that everybody sends us UTF-8 everywhere and we don't do any validation or conversion or anything. So I think here in input element create layout node, we are just going to go ahead and maybe log input element. We'll say that we have a input element of this type with some value, right? And then we can see what the value string is, because here for submit we create a button, and for every other input type we create a text box. So you can see here that we compute the text width by asking the default font what is the width for the value of this input element. So I think let's just find out what it is doing. Probably it's some Swedish characters that I'm getting, because Ali, who's been working on this, he is in Iran, I think, and he had a screenshot of it working, and presumably that was not using Swedish characters. So google.com. It is pretty cool that HTTPS is working, by the way. Okay, so blah, blah, blah. Okay, so here are our values. Okay, so this one is failing, and we can immediately tell why, because it's saying search on Google in Swedish, and we have these invalid characters. So presumably it's like Latin 1 or something like that. And when we get text from a web page, it might be in any text encoding. We can't control that, right? We just have to deal with whatever comes in. And the text encoding should be communicated to us through, I guess there are a couple of ways that you can communicate it. You can put it in the HTTP headers and the response headers from the server. You could put it in a meta tag, like a meta name charset, I think. That's a thing, right? Let me look that up. Meta charset. Yeah, that's a thing. It's not meta name charset, meta charset. So I don't know exactly what they do to communicate this to us, but we should probably figure that out and then get that information, and then once we know what character set they're sending, we can pass it through some conversion function that turns it into UTF-8, which is what we want internally. So I guess that becomes the mission for today. And before we can make any good progress on that, we don't have access to the HTTP headers, so we're going to have to give ourselves access to those as well. So let's see, how do we do this? I guess let's think about where we want this input. So we want this for the HTML parser. When we call parse HTML document, we basically want to know for sure that what we're giving him is UTF-8. I think that would be the easiest. And how do we, well, who's calling this? Or should he care about this? We could have it as an argument. We could say like, we could pass an encoding as an optional argument. Encoding. How do we encode this? Let's have it as a string right now. Text encoding is defaulting to UTF-8, maybe? I don't know. Something like that. And then because then all of the existing callers will just keep working, but if you pass something, then the parser can know to convert it. So how do we do that? That would be here. So let's say like so if encoding is, I mean, let's just pretend that we're telling it like the Latin 1 encoding, right? And then if we get this, then what we'll do is string HTML. Okay, and then let's say if encoding is, this is not what it's going to look like in the end. We're just sketching something out here. Else, let's assert not reached here. Unknown encoding. Okay. And then for UTF-8, we can just use the raw HTML as provided. And if it's Latin 1 or ISO 8859-1, then I guess we can just, let's make a quick and dirty converter here that just replaces anything that's not valid UTF-8 with question marks. So something like this. I guess we can say raw HTML lang builder append raw HTML I so if it is above hex 80, about 128 or higher, then it's not valid ASCII. So then we'll just say question mark. Otherwise, we will say the character. And then HTML is builder to string. All right. And convert to maybe to UTF-8 raw HTML coding, something like this. To UTF-8. Thinking how we're gonna factor this. Maybe we'll end up putting this in a new library, actually, like a text encoding decoding library. But right now we can keep it here just while we are sketching things out. Okay, so that's to UTF-8, and then probably do this for the fragment parser as well. So here it's just a matter of passing that along. Wait, what am I doing? To UTF-8 raw HTML. Encoding. Okay. Yep, that works. So let's try just sending this into this guy here. So when we do parse HTML document in the HTML view, let's just say, we'll just pass him this thing, pretending that everything we get is Latin 1 encoded. We'll see how that deals with google.com. And in fact, maybe we should add a Google bookmark. Google. Okay, and just for testing that out. Click. Oh shit, look at that. All right, we are in business. So there's our question marks. And this is actually pretty awesome. It's Google rendering on my machine for the first time in our browser, which is, it really is amazing how far we've come here. Just the idea that we will be loading google.com on a new system, on a new, completely new kernel, new network stack, new windowing system, new browser, new everything here, like, and with a new TLS stack. Very, very cool. And super awesome job by Ali and Itamar and Dexys TTP and everybody who worked on the enabling the HTTPS stuff to come alive. Very, very cool. That was the last missing piece. Anyway, we got work to do here, so let's take a look at the DOM, what we have going on. Because I'm kind of wondering, like, where does that character set come from? So here it says meta content charset UTF-8. And I don't see any meta about Latin 1 anywhere. So why are you sending me Latin 1, bro? I don't know what I'm looking for in here. I guess I'm looking for this button right here. So maybe that's in the form here somewhere. Table something something. That's probably the search field. I guess these are like input hidden. Probably wouldn't be so hard to get rid of those. But let's not get sidetracked. Oh, that's fun. This is the button right here. Sec for Google. So I mean, now we have converted. We've converted them to question marks. So we don't know what the original was anymore at this point. But why is this like it's not UTF-8, dude? So you're lying to me. Let's see what the, no, we're gonna have to look at the headers then. So I guess we'll just look at the headers. I Yeah, let's look at the headers. So in HTTPS protocol, HTTPS job, let's see. So this is the input processing in the HTTPS parser, basically, which is kind of copy-pasted from the HTTP parser. It's a little bit unfortunate, but it is fairly simple, although at some point we should maybe see if we can share code between the two. I don't know if that's going to be feasible, hopefully. So where are we here? Here is the in headers state. So here we're just going line by line, because HTTP headers are just header name, colon, and then the header value. Very simple. So in headers, parse those, and here we can print out all the headers. So let's do that. I guess this would be in lib HTTP, which goes into protocol server. Okay, so now we should see some header spam. Poof. Yep, did we see some header spam somewhere? Where did they go? Okay. Here we are. Content. Aha. Content type is text HTML, charset, ISO 8859-1. You madman. Okay, so this is where we get this information from. And now we have to, so because of the way network loading works in our browser, we don't actually talk to, google.com in the browser process, because I figured it would be better to have a separate process that does the networking for many, many reasons. Especially now that we start to do much more complex things like TLS, then it's nice to have that segregated from the browser process. So we have the protocol server, which we'll find if we look for it somewhere here. This guy right here, he is doing the network fetching. So this presents a problem for us because we just have an API, and the API to protocol server is very, very simple. We say start a download with this URL, and then we get a download ID, and then the protocol client will eventually get notified that there was some progress on a download ID, and then the download was finished for download ID. So I think here we're going to want to include all of the headers. So that's going to be like download finished. We'll say it would be like a vector of, what is this even? It's like a, it's not a string, it's a string pair. It's just a key value map, basically. And we don't have some good IPC type for this, but we could invent one. We could just call it like a dictionary. That might be nice. Or hash map of string to string, that could also work. What is the easiest thing? Then we lose the sort order. Maybe the best thing to do here is to have a, I don't know what's a good type here. Let's invent something new, a dictionary. And this will be some IPC class. We say IPC dictionary, headers, and it can be empty. that's fine. Okay. And then this will be like the response headers. And this is not going to make sense for all protocols, right? Because protocol client is really protocol agnostic. HTTP and HTTPS, they're just two of the protocols that we currently implement, but the idea is to implement more protocols in the future. But so this one is kind of HTTP specific, but I think it's okay. We'll just add it, and it can just be empty if you're doing for something else. And then it would be good to have an API here for also passing a dictionary of request headers, right? So you could say like, I am this user agent and things like that, but let's not get into that now. We will need an IPC dictionary object thingy, so let's invent that. Dictionary. And oh shit, I need some license headers. Dictionary. All right, here we go. Yes, I'm writing this, and we are in the IPC namespace, and we're about to invent ourselves. Let's see, do we care about order? Let's say that it's unordered for now, unsorted. And then we can just use a plain hash map for this. For now, maybe it will be a string hash map. So public. My phone keeps blinking and buzzing. I don't know. But I'm just gonna ignore it right now. So in here we want values or entries. Okay. And then let's make a very simple API here, because the idea is not to have a full-fledged hash map, but rather like a very, very simple API where you can add things to it. String value, set, and then maybe we will have an iteration function for each entry. Callback. Then we will just call the callback. Like that. Yes, and maybe some. I feel like maybe this one is going to be useful. I'm not even sure, but it doesn't need to. We don't need more than this, I think. At least not for a beginning thing. So then, when we want to send this, so we need to know how to encode and decode it. And the way we normally do that is, I already forget, is this way, right? So let's look at the way rect is encoded. Oh, it's not encoded, it's only decoded. Oh, I didn't templatize encoding yet. Oh shit, wait, am I looking in the wrong place? Encoder. Okay. I thought it worked in a different way, but it does not work that way yet. And we do it this way. PC forward class dictionary. Cool. And then in IPC encoder, dictionary. So in order to encode this, we'll say if value or if dictionary. I guess actually shit, I forgot something that we do need. We need like a size to know how many entries there are. That's how we know how many entries are coming up. So return, no, hold on. So wait, what's the API here? You just stream into yourself, okay. So this dictionary dot size. We will do that as a U64 just to be sure that it will always fit, and then now we call that API that we have for each entry. This key auto value, all right. This key value. I think that'll make sense. So then this now we're just telling, okay, so the dictionary is here, and then this has this many entries, and then for each entry we send first the key and then the value. That's pretty good. And then we can't call this because it's not const, which it should be. And then we just return this. Okay, so that's a pretty good encoder. What about a decoder? Forward. So decoding will be very similar. So decoder, decode, dictionary. I guess size. So wait, no, if we use U64. Size. So if we had a read failure, then return false. If size is obscenely large, or let's say numeric limits U32 or I32 max. Let's assert not reached in that case, because then we got issues. And then now we know how many times to read strings. So for size t I less than size. Wait, I feel like this is, no, this is probably okay. So now what we want to do is key string value. Then if decode key return false. If failed to decode value, return false. Otherwise, dictionary add key value. So that looks pretty cool. Return true. Okay, great. So now we have a basic dictionary type for our IPC library. We need to teach the code generator. Almost forgot. So, or wait. We shouldn't need to, because there's already overloads for everything. Oh, dude. We might not need to do anything for that. Okay, so let's see how that works if we just try to build stuff. see, protocol server, response headers. Oh, right, we need to include that thing. So that's the only thing we need to do in the code generator, is just add and include. That's okay, it's a small header. We could get smarter here and only include dictionary.h if the IPC definitions actually need that header, but I think it's not a huge deal. It's such a small header in this case. So let's see. Incomplete type IPC dictionary. Why? Protocol client endpoint. Well, you're not including that thing, are you? So what if we start you over? Okay. Now we are just missing a parameter to that, or an argument to that function call, which is great. That's just our headers missing. So here we can just say response headers. And then let's say that dictionary response headers. If download, how do we get these from the download object? Let's see. So download is a virtual thing. So we have an HTTPS download, which inherits from download, and he has an HTTPS job internally. Let's see how this is hooked up. Right, so we instantiate HTTPS download with a job in hand, and then we set up a callback when the job finishes. We will call did finish on this download object, providing it with the success state in this case. So I guess what we can do here is to just transfer headers if we're finished. So wait, how do we even communicate this? I guess a download object could have headers. So then we'll say like set response headers, job, response headers. Okay, that was pretty simple. Oh, wait, hold on. We'll do it up here next to set payload. See, that even fits together. And then we do a null check of the response. We can even write it this way. For maximum clarity. And then set payload is a download level concept, so we'll just add set response headers. And for now, we'll say that it's just a hash map of string to string. Doesn't have to be fancier than that. And string to string and response headers. And we need ACK hash map for this. Okay, so that's cool. And then, oh, we should actually expose these guys. So const hash map of string to string response headers. Okay, now you can look at it from the outside. And then finally, here, when we are about to tell the protocol client, so we're sending a message to the browser here that a download finished, we'll now look at the response headers, and actually, download response headers. So if there are any response headers, we will add them one by one to the IPC dictionary. So that's pretty good, I think. Yeah, I like it. It's very expressive, very nice. And then we never implemented set response headers, but that's actually a really, really simple function to implement because it could even be in the header. But let's see, set payload, let's do it here. Set response headers. Response headers, response headers. Okay. And, you know, let's make sure that we do this. Since this is a bit copy pasted, let's make sure that we do this in the HTTP version of this as well. And then we'll take a mental note that we should look how copy pasted this is. Oof. We'll take a mental note that we need to unify these things somehow. Or at least +1 the already existing mental note. Okay, but that's pretty good though. So then we should be in the clear with the protocol server, although we are missing, oh, we didn't rebuild libIPC. Okay, so now, in theory, where we receive this download finished, which would be in the protocol, libprotocol, which is a library that the browser uses to talk to protocol server. When we get the download finished here, we actually we have a client-side download object. So here we will include the response headers in did finish. So const IPC dictionary response headers did finish const IPC dictionary spoons headers. Okay, and then where do we give you those things? I guess they'll come in on finish. That's where we give you the success, the payload storage if you want to partake in ownership, and now also response headers. Maybe we should convert it to a different type so we don't have IPC types in our public interface here. I'm not sure exactly what would be a good type for this, so we'll just go with a hash map like this. Response headers. And let's see, on finish, spoons headers. String, response headers. This is kind of, it's a little bit sad. Maybe we will let's make it a little bit easier for ourselves. We can at least do without that copy here. So response headers dot entries. Okay, and then on finish is of course used in libweb's resource loader and in the little pro test program. So here we'll need to actually take this param, response headers. So when we get them here now, let's see. This is when we have a successful HTTP or HTTPS download in the web engine. Should we just pass it to the success callback maybe? The success callback is a byte buffer taker. That could work. Yeah, we can include it here. So hash map string string response headers. It's a little bit awkward API. We're probably gonna have to come up with some kind of like request and response objects for libweb eventually. Right now, we've been happily just passing this big byte buffer around, but going forward, we're probably going to want to change this system around a little bit, but we don't have to do it right now. So if we don't have response headers, like in the case of data URL, we can just pass an empty response header map. That's fine. Same with file protocol. And here we can just pass the response headers that we got. Okay, so I think this is not going to build because now people have the wrong signature for the success callback when they call a resource loader, or at least I hope it doesn't build. Yeah, right. CSS. Oh, where are these? Style, value, loader. So here, like, we don't care about the headers in most cases. We do care when we load a document, because then we have to look at the headers. Maybe we should care. Like, I'm thinking, should we care when we load an image? But no, we shouldn't, because even if the headers say like, oh, this is a PNG, but then we look at the content and it's actually a GIF, clearly we're going to ignore the headers. So the headers are more like a hint than anything when it comes to images. HTML image element. Yeah, you get one of those as well. Link element. Now this one, here we might actually care a little bit. We'll ignore it for now, but same with script. Like scripts and link elements, these can clearly have strange encodings. So we're going to need to care about this at some point, and I think that we'll have a different API, I think. Not this thing where you just get a call at your list, or we'll make some kind of a request and response objects, I think, but not right now. And XHR needs this as well. And then can we finally get to HTML view, which is where we wanted to do this. So here, this is the particular one that we were interested in, response headers. Okay, and look at us doing this. We're not going to do this. We're going to say auto encoding is encoding from headers. Or wait, hold on. Let's see. Encoding if response headers contains, if it contains content type, then found. You know what? Let's just dump all of the headers. to see if we even have them all at this point, because we've been doing a lot of plumbing right now, and I'm a little bit unsure if we actually got these things all the way here. So response headers got header. Just something simple like this, right? So we can see them. And then if we do have content type, I guess what we want to do is like encoding is encoding from content type. Or we'll do it this way. content type value is response headers get content type. Something like that. And then we'll say string content or encoding from content type. Trying to figure out encoding from this string, and then we'll just return UTF-8 because, or no, let's return this so that we don't get a crash. No match for call, this and that. Okay, so what did we forget now? Load, spoon setters. Where are we even? Load. Okay, how did I just mess this up? I have a return statement somewhere with a value and a function returning void. This is not the most readable thing. Cannot convert here. Oh, did I say? Oh, shit, right. Okay, yeah, that's going to confuse him. And then what else is wrong? The second call here, right, the favicon. I thought we had only one call. Okay, so now what don't you like? 432, we have yet another call. Okay, so there were more calls. I thought that this was just some incomprehensible error message, but it was in fact that we had more calls to resource loader load. So, oh, we forgot to update load sync with the correct signature. String, spoons, heaters, and you also don't like on line 56 that I didn't set this up correctly. Of course you didn't like that, that would have been crazy. Cool. So, will this monster run? Let's make sure that we build things, because now we were changing around libIPC a little bit, and changing libIPC around is usually pretty good at screwing things over, so we'll see. I mean, screwing things over unless you do a full rebuild. Although I don't think we did any incompatible changes this time, because we were just adding the IPC dictionary. We're not messing with anything that would screw up the existing like Windows Server protocol. But maybe there's something I'm not thinking of. So let's see. Right, build times. The build times. Well, these have to be linked anyway once libGUI is finished. There's a bug opened on the Serenity GitHub about CMake, and doing a little bit of work on that. And it was Brian who opened it. Let me see if I can find that. Right here, CMake build. He wants to start a discussion for what's left in terms of work for your experimental CMake port. Yeah. The thing that's just missing in the CMake branch is taking it all the way to actually working. So I got it to the point where it could basically build all of the software, but it couldn't do everything in the right order. So you had to first make sure that you built libc manually so that you would have like the CRT0 object file, and then you basically had to do a few manual steps before you would have a full build, and that was the thing that I just couldn't work out how to do that correctly with CMake. So I think if somebody were to pick up the CMake branch who's really familiar with CMake, they could probably get it working pretty quickly. But for now, I've kind of not working on that because I kind of got a little bit tired of it. But the more I sit and wait for this type of stuff, the more I start to think that, maybe it is time to care a little bit. Anyway. I'm not going to complain as much in this video as I did in the last one about CMake or about build times. So, come on, bruh. Just hurry up. I think another thing that is slowing down our build is certainly linking the userland directory, because we are linking the userland, all the userland programs, against more and more and more libraries, and we could probably calm that down a little bit. Anyway, now we are up, and if we go here, then what happens? Oh, okay, we got header. And look at that, we got all the headers in the browser, libweb, and we are trying to figure out encoding from this string right here. That's really cool. That means that now we just have to work out how this content type header, like what the format is. It seems pretty clear that it's like MIME type semicolon white space and then charset equal. Like that, I think that's pretty typical, but let's look it up. Header. Tell me about it, MDN. You always know stuff. Syntax. Directives. Ooh, that's a fancy word. Okay, so media type. Well, I guess this is the media type. Boundary. Oh, that's from multipart. Okay, well, multipart is very far away. We're not going to care about that now. But charset, yeah, we can definitely get the charset out of this guy. So let's see, HTML view, content type. Let's see, so the encoding from content type, that would be something like I guess we'll split content type. Wait, I'm not saying that correctly. Content type split semicolon, and then, or I'm thinking what's like the best way to do this. Maybe we'll say, do we have content type index of another string. Perfect. So we can look for this string, and then we just grab whatever comes after. It's a little cheap, cheesy, but we can do it. Offset. So if it has a value, then we are just going to return content type substring starting at offset value plus 1, 2, 3, 4, 5, 6, 7, 8. Cool. And then offset, or no, it will be the content type length minus offset value minus 8. Something like that. Otherwise, we will say UTF-8. Okay. Content type header says, or I think we should be print something for this. We can do it in the caller rather. Encoding from content has encoding claims to have encoding, or server claims content has encoding. Encoding. I think content. Yeah, because it might not be what the server thinks if we have a fallback. So that's okay. It's a little bit murky, all of this stuff, but I think we're okay. This is definitely not the right layering here that we're doing. Like this shouldn't be happening in the HTML view class. It needs to be at some other layer, but we are just trying to make things work, so that's fine. Okay, and then wait, there's so much noise here. Oh shit, wait, did I even rebuild? No, I didn't relink the browser. I think we're good now then. So let's add the dictionary type to libipc first of all. My goodness, we have a lot of changes here. libipc add, oh shit, wait, we need the IPC compiler as well. This should probably be together with libipc at some point. libipc add a simple IPC dictionary type, string keys, string value. Yep. And we have a bunch of changes, but let's see that this still works when we do the working out of everything ourselves. It didn't work. Crap. Oh, look at that. I think this content has this encoding, but it's uppercase, so that's not going to work. Let's be a little bit cheesy here and do 2 lowercase. That's very cheesy, but it's okay. Oh. I just want to load Google. Okay, it finally loads with us looking at the header to find the encoding. I think this content has this encoding. That's really great. Okay, so we added something here, right? We turned on this debug logging. Let's turn that off again. And now we just have a whole bunch of, these changes are basically all dependent on each other. But it's okay. So lib protocol, lib web, protocol server, yeah, all of this stuff. Okay, holy moly. Protocol server plus pass HTTP response headers to client. We now plumb all of the HTTP response headers from the HTTP, yeah, from web servers or to the client side. This is actually, okay, well, this, now we're doing two things in this commit. I don't like it. I don't like it. So we can probably simplify to not do two things in this commit now that I think about it. But let's see, how would we do that? First, let's just, let me edit this and make it look proper, and then we will have a separate commit just for this guy. Base, add browser bookmark for Google. That's pretty nice. And then I think we can just take out the encoding parts. So we'll skip the HTML parser. So all of the lib protocol stuff gets to come. All of the protocol server stuff, the pro tool, and stuff like image element and so on. These guys are just adding that that parameter so that they get the response headers, but they're ignoring it, so that's okay. And these guys are just plumbing everything through. And then the stuff we have remaining. So this is, here is one hunk related to the response headers. Here's another, and the rest we can skip. Okay, so we can add P to this guy. Say not you, but you, but not you, but you, and you. Okay, I think we are good. Lib protocol server. Plumb HTTP headers to the client. Not plumb, pass. Now store the response headers in a download object on the protocol server side, and pass it to the client. I'm finishing up. Download. Response headers are sent, are passed as an IPC dictionary. Yeah. Ta-da. libweb. Don't, or do some handle, content type, text, or something or other, charset, ISO 8059-1. A little better. Handle ISO, no, hold on. Handle ISO 8859-1. Web content a little bit better. We now look at the response, HTTP response headers for a content type header, and try to parse it if present to find the text encoding. If the text encoding is ISO 8859-1, we turn all non-ASCII characters into question marks. This makes Swedish Google load on my machine. Right. So that took a moment. It was a little bit roundabout. But let's see, maybe we can, what would be like the nice approach here? So at least for the text encoding stuff, I feel like we could have a library for this. So like lib text codec, maybe, lib text codec, maybe text encoding, text decoding, text codec. Yes, we will call it that. And in here, we will need a makefile. So we'll take the one from libtls because we just need any makefile. And then, why does it say TLS objs? Here, let's see what we add in this guy. So we'll want something like ISO 8859-1.0 and a text decoder, maybe. Maybe we'll just start with a text decoder object or class. Text codec. Text codec. Text codec. Dutch text decoder. Okay, great. Let's see if we can make one of these things real quick. Text decoder. Wait, I wrote this. So cling@serenityos.org. Please don't send spam. And we'll need the header file as well. Oh, that's nice. Pragma unse, namespace, text codec. Do I like this name, text codec? I am immediately changing my mind and renaming it to libcharset. Boom, libcharset. Yes, I like that better. So then it would be namespace charset, class text decoder, maybe even decoder. Wait, do I like this? Oh, these library names are screwing me up every time. Let's not save that, and let me go back to my original thought. And we will just call him decoder. Otherwise, it's a bit of a mouthful. Okay. Class decoder. Okay, so what's this thing gonna do? It's gonna have I guess a decoder will take input and produce output, basically. So maybe it will, let's say that like all we care about really right now is producing UTF-8 string. So we'll have something like UTF-8. Something like this, and back, forward, string view. Yeah, so you get some byte. Really, what you get is a byte buffer. That's probably okay. Yes, this will be our interface, and then we'll have an ISO 8859-1 decoder, or maybe we'll call it Latin 1 decoder, public decoder. Okay, and then do UTF-8. Let's see, decoder. We'll have an API where we fetch a decoder. So decoder for encoding, or code string encoding, something like this. And then you can call that. And then the way we'll use this in HTML view, or HTML parser rather, is we'll say so we'll say auto decoder is X codec decoder for encoding. And we'll assert that we know how to decode this. Otherwise, yeah, we'll have to deal with that here. And then we will just return decoder to UTF-8 input. Yes, just like that. And then this logic here will go in text codec decoder. To UTF-8 string, const byte buffer input. Thinking is byte buffer the right API? We could allow you to pass a string view. It's not such a big deal, actually. That's fine. String view. And for our very bare bones encoder, we'll need string and string builder. And here's our cheesy Latin 1 implementation. Okay. and decoder. So we'll make one for UTF-8 as well, UTF-8 decoder, which will just be a pass-through, really. But that's okay. So say string UTF-8 decoder to UTF-8. Turn input. Yes. I'm thinking like, this is a little weird the way that this, like my brain is having trouble parsing what this means, but like it means that we're decoding some UTF-8 to UTF-8, and this is our UTF-8 input. Right, okay, and then, let's see, so we'll instantiate some codecs here, I guess, or let's do that on demand. So let's say decoder, these don't, let's not have state in these guys, at least not right now, so we'll just say that decoder, Latin 1 decoder, blah 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 blah. Something like this. Oh, and then I guess here we can, let's see, if encoding equals ignoring case, ISO 8859-1, then return Latin 1 decoder. Okay, so this API is by no means perfect, but I think it'll work for what we are doing right now. At least it's a bit better encapsulated, and then we can start to flesh out better stuff later on. Wait, now we have to actually update all the make files. Text codec. At least this will make it easier to add more encodings. Web, text, codec. I'm gonna need this in userland, aren't I? Text, codec. Look at everything that userland links against. It's so much. Forgot about text editor. Text editor is definitely a good candidate for text codec. Wait. Oh, I'm not trying to edit. Because it would be good if you could open random text from other things. Like if we don't recognize what it is, we could ask the user, like, what encoding is this? Things like that would be cool. Okay, this is a little bit silly. But it's like this right now because there's no way to specify that like a library depends on another library and have it automatically pull that in. So we are stuck doing adding it manually to everybody who depends on it, even if it's like an indirect dependency, like libweb depends on libtext codec. So still, it's okay. We have built, and we're still running, so we can't create a new disk image while it's running. Click, and we have loaded. Look at all this debug output, so much of it. But this is pretty cool, pretty cool. Very nice. So we didn't make much visual progress here today, but we got a lot of stuff done. So now we have HTTP response headers available to us in the browser side, which means that we can start to look through those for things we might be interested in. Which there's certainly things coming to the browser via headers, so that's really good. And we started fleshing out a little bit of text encoding logic, which I'm sure that we can do better with. Like, obviously, we're not supposed to have question marks here, but since we're using a custom font, I can show you that even if we would translate this to UTF-8, our font only has the English alphabet anyway. So I don't think I would like to sit and draw Swedish characters and things like that. But I'm not sure. Maybe we'll do that. I don't know. Maybe we should have a more Unicode capable font format before we start worrying about this, because right now the font format is like 256 glyphs and that's it, because it was really only designed to support 256 glyphs per font. I don't know, but anyway, this is pretty cool progress, and now we can actually reliably load Google here despite it having a character set other than UTF-8. So this will be the end of the video. If you made it this far, then I thank you for watching, for hanging out, and I hope that you saw something interesting today. And yeah, it was certainly felt productive. Thanks for hanging out. I'll see you next time.